Imagine that you are walking down the street and the ground beneath your feet suddenly begins to shake. It shakes hard enough to make you lose your balance and fall down. Now imagine the ground shaking so hard that the buildings around you begin to crumble. Chunks of concrete hit the ground. Telephone poles tip over. Cars are tossed around like toys. Then the street cracks in half. Underground pipes explode and plumps of water and gas shoot into the air. Sounds scary, right? This is an earthquake. An earthquake can strike at any moment without any warning. Moreover, they can take down the big structures and split highways into pieces. It is easy to conceive Earth as a solid ball, but it is not solid. One of the main reasons earthquakes happen is that the outer shell of the Earth is broken up into separate sections called tectonic plates. Imagine it as a scoop of vanilla ice cream with one of those delicious chocolate shells on the outside. If you put your hand over the shell and squeezed it gently, the shell would begin to crack in many places. Each of these pieces is called a tectonic plate. The lines where tectonic plates meet are called plate boundaries. Let us use our ice cream comparison again. You would see white lines of vanilla ice cream between the cracked parts of a chocolate shell. These white lines are like plate boundaries. There are 8 main tectonic plates on Earth, plus many smaller ones. Each plate is huge. Believe it or not, these giant tectonic plates actually move. Even though they are made up of tough material, they sit on a different material that is hot and rubbery. If you cut the Earth in half, you would see that it is made up of several layers. In the middle layer, you would see a circle. This is the Earth's core. The core is surrounded by a series of rings, and each larger than the one before it. The rings represent the rest of the Earth's layers. Tectonic plates are made of the top 2 layers. The Earth's crust and uppermost parts are known as the mantle. The uppermost part of the mantle is relatively cool and fragile and distorts elastically. The Earth's crust is not a single even layer. Rather, it is composed of segments called tectonic plates that rest on top of the gently flowing and moving mantle. These plates do not stay still. They move around the planet, sometimes rubbing against each other or shifting into each other to make mountain ranges. In other areas, where plates are moving towards each other, one plate is pushed under another plate. These areas are known as subduction zones, and the world's biggest earthquakes normally happen in these areas. Earthquakes are measured by devices called seismometers that identify the waves generated by seismic waves as they move through the crust. The idea of a seismometer is very straightforward, where the weight manages to stay quiet as the Earth moves and the relative movement can be represented on a wheel of paper as a zigzag line. The higher the vibration, the longer the zigzag. Latest systems use electronics to provide more detailed results, but the principle is the same. The magnitude of any earthquakes used to be defined according to the Richter scale, which analyzes the comparative strengths of various earthquakes. The scale is logarithmic, which means that an earthquake of size 6 is 10 times more powerful than one of size 5. A magnitude 7 earthquake is 10 times more powerful than a magnitude 6 and 100 times more powerful than the one of magnitude 5. Although these days the term Richter scale continues in the media and general use among the public, experts now use a more precise physical mode for measuring the intensity of an earthquake, which is known as the moment magnitude. This includes how powerful the ground is or how much strength is used to break it, how much original displacement happens, and the number of rock that is relocated. Earth is not as rock solid as it may appear. It is a vibrant planet with numerous movements taking place under the surface. As experts continue to investigate its internal operations, we may be ready to completely predict the cruelty of an earthquake before they occur. Until then, there is still a lot to learn. That is all for this video. Do like, share, and subscribe to Explified.